Okay, I do want to say something, which is whenever I took a break, I realized the mistake I made, which I feel is important to just share that what I think I made the mistake. So during the last lecture, I gave you a example of a serial killer, the random serial killer. I emphasized about an hour ago, saying that, oh, one of them is a computer science student, and it's not only a computer science student, it's a very good one. It's a very good one. It means he accomplished a lot during his 4 years. So I think that was a mistake. I always think we shouldn't emphasize during that situation. It's good for people to mourn over we lost someone that's precious. But on the other hand, I do want to say this is uh, my I would say how do I describe this? It's my opinion that a life is a life. So when we're doing anything, because you guys will be engineer, you guys will be designer, you guys will be people who create services for our society. And in our society, every life is precious. It doesn't matter he is the best person or for some standard, he is the lowest status. It's still very precious. So that's why I feel I made the mistake because I kind of emphasized that particular point. I should actually just say, hey, one of the three person got murdered was a homeless person and that is still a very precious person that we lost. So I want to just give you a kind of correction about what I did during the last lecture. Okay, so now we're coming back to here, and I say, okay, I want to have a risk score. So now I don't have a clear idea how do I do that. Maybe it's age, maybe it's mental health, maybe it's due to the special situation. So let's simplify. Sometimes as a programmer, we can actually start with something simple. So I can just model a risk as a value between 0 and 1. Okay, given that 0 is the lowest score for the risk. When you have something that's close to 1, that is actually going to be pretty horrible. And the other thing is that this risk score may be dynamic due to the time, which means that this particular person might not be always risky, but only during certain time. He might be very risky, and maybe it's just all the time. For example, the time could be the example, could be a final exam. Okay, so we can actually deal with that. Okay, and if you want to make it more complicated, this could be due to different location or due to the alcohol issue. When you just finish drinking something, your risk will be higher. Okay, so this is somehow we imagine there is a computational system that's keep updating the risk score for all the person at all time. Okay, that's great. And the second things we need to monitor about this person is about, I would say, trackable person, almost like a trackable person or locatable person, which we know that where this person is or whether the person's activity related to whether he's related to his control about a car or a bike. Okay, so those are the information we need to model, right? It's a person and the risk score and activity, including where he is, including the GPS location. Okay, that's the first thing we need to do. And the second part I need to do is about the person, it's about location. So we already have the location, which is the location is a GPS location. Now we already know that. And the location also has a label because we want to see whether this is a university role or this is another part of the campus. So we have some kind of name and the GPS location. And then with the GPS location, we actually have some kind of time information, which is the timed information is at this time, what is the aggregate risk score at this location? Okay, so we have because we know the location, we know when will be this happening, that how much vehicle will be passing through this at this time, and who are the driver, and also what are their risk score. Okay, so we're going to have this location. And it turned out that these things add together, we can have, sorry, I need to go back. And we will have a location risk. This is a time location risk. Okay, we can have this, and then we can put this information together. Then we can decide to do the next one. It's called navigation. And the simple way about navigation is, of course, you have the starting point, and you have what we call the destination. And the second thing is you have a sequence of location. And then you can have a risk score associated with the whole pass. The whole pass, meaning that all the location that involved. All the location associated with this particular pass or sequence of location. Okay, this is kind of already describe what kind of information we probably are most essential to the original goal we try to accomplish. Number one is person. Number two is the location. Number three is the navigation. Oh, by the way, the passes not only have a sequence of location and also have a different time, because you're going to spend some time to cross this location, and depending on how fast you walk, and sometimes the risk might change during this passing through this location. Okay, so now we need to come up with scenario. Based on this idea, we're going to create scenario now. So in the scenario, let's try to model a few JSON. I'm going to use this JSON to represent. Let's actually say we have a person A. We have person A. Let's try to write down a JSON. So I'm going to focus, because of the time, I'm not going to write every single detail. I'm going to assume I already have a person.h portion, which is already there. So I'm not going to write this part. This is ... for the original person.h. And then I'm going to model the second part, which is the risk score. The risk score, and the risk score is actually associated with the person's time and the location. So I'm going to use a sequence, I call it I call it risk. And the key is risk. Risk is an array. And inside the array, the way I model, a bunch of this risk object, and I would say risks, sorry. Each of this is a risk. A risk will be, number one is a score, say 0.5, moderate risk. And the second one I would say is the time. Duration, I should say duration. Duration, which is a time object, which is also an object, which I'm going to neglect. This part is not just one time stamp, but from one time to the other. That's the duration. So for all this duration, this person will have this particular score. And then I have location, that this score is associated with certain location. So the location is also an object, is related to maybe label GPS. Okay, let me check if this actually fulfill what we talked about earlier. So we have a mental health, we have the time, okay? We have the duration of the time, which now is the final weeks. And then we have the score, and then we have the location, okay? Location, and so I just basically picked oh, wait, I think that's actually fine. The only thing I want to say is, I'm assuming, I should probably make a comment here. Assuming if you're having this risk score, it must be, I would just leave it like that. I think this is enough for you to remember the risk. Let me actually just make a 2. So we will have this person. Let me make it smaller. Maybe score 0, 0. This is another location. And another duration. So you're essentially using JSON for each of the person. You collect the risk score for all the time. And then each of this likely to represent this person is manipulating a moving vehicle. Okay, he's riding bike, or he's driving a car, or he's actually riding a bike scooter or something like that. Okay, so you have each of the person have this, and you're just keep collecting this. By the way, I just want to tell you that this information is not that hard to collect it. I mean, by the way, Google already collects some of the information. For example, Google will know that whether you're walking, or you're running, or you're actually on a vehicle. They can look at the dynamics about your GPS location. The only things it's harder for them to figure out whether you're the driver, or you're basically just a passenger. Sometimes that is not so easy, but assuming we have a way to collect this information to make these things scenario realistic. Okay, so you're going to, based on whatever scenario I mean, I'm only provide a sketch about a JSON, but you should be able to, for your final project, you probably want to make it a lot better, to make a real number, and for your scenario. Okay, it looks like this. You can create a JSON for a person. Okay, any question about the person? Okay, so before I introduce the location and the navigation, I want to actually move to the next step to tell you what. So we're already in the scenario, we're developing the JSON. So now I'm going to use the sketch I just developed to implement a person class, which is going to change to C++. Let's actually do that. So I will call it, let's CP person dot H. Let me call it person with risk. Person risk. Okay, I have now have a new class called person underscore risk. Maybe I should use traceable person. I'm gonna take a look. What is my traceable person? I did use this traceable person, and what did I do with traceable person? It's the same thing. So traceable person is a person, and traceable person has a personal time GPS record, which is a GPS trace. Ah, you know what? I think I can do much easier with this. Okay, let me go to trace using traceable person. Let me first take a look. I realize I don't have to change the traceable person, but I can use personal time GPS record in the GPS trace. So that's how we always try to find something which is let me see. I call it what? Trade personal. Okay, this is a class called personal time GPS, has some kind of identity and a vector about timed location, timed location. So now I have to go to the timed location. So now let's look at time location. So time location, has time, and that's it, right? Has only time and location, there's two. Okay, I'm not going to use inheritance in this case. I will explain to you why when I have more time to do this. But I'm going to directly modify this because this class is the closest to what I want because I already have a time, I already have a location. The only difference is that the risk score here is a location, but location is already have it. But the time is not about a single time, but it's about the duration about the time. So I'm going to leverage this to actually change. I call it. I'm going to CP time location.h to timed time location risk.h. And I'm going to modify timed location risk. I'm going to change this to risk. This is time location risk. And I'm going to change this to be time location risk. Should I inherit from time location? Maybe, maybe not. I don't want to do this. I'm going to do this too. Time begin and time end. Okay, now you can see that I have a location, I have a duration of the time for this location, and then I can add another double, which I call the risk score. Okay, of course, I have to change this to time, location, risk. Time, location, second. Okay, good. I recover. I'm glad I realized this immediately. Okay, but then the time, location, risk, I need to have two arguments. I need to have a JV time because now I have a two time beginning and time, and then I need to have a double, which is the risk score. The constructor need to have all four things. Okay, and then I have the rest of the stuff. And I can still do the TL sort. I can still do TL unique. Of course, this has to be TL sort. I can still have this two function. I call TLD, TLR, time, location, risk, and TLR. Okay, so now I create this class, which is called time, location, risks. And now I can modify my traceable person. So now if I go to personal time GPS record, I will use, instead of use a time location, I'm going to use time location risk. And then what I'm going to do is time location risk. I'm going to put this as a traces. Okay, look at what I did. I just make a very quick modification. I kind of update one of my class called time location. I change it into another class called time location risk, which I modify two things. Number one, I add a risk score. Number two, instead of one time point, I make to be a duration, a time begin and time end. And then I actually update my personal time GPS record. And then in this case, I can have, now I call it traceable person. I'm actually using one of the class we introduced earlier, which is using one of the argument is personal time GPS record. Now everything should work. I did not even modify anything to the person or traceable person, but then through this, now I actually be able to model a traces for a person which expose the risk score of the whole thing. Okay, so I want to take a small break here. I want you to kind of digest a little bit what I just did. And I believe by making this change, I actually be able to fulfill what I want to do with the person, which is this part. Can someone check whether whatever I just modify, is this fulfill whatever we define as a person, which is contain the risk score and track the person. The last part activity, I kind of the way I do it is if you're riding a car, your risk score is going to be something according to your situation. But if you're walking, let's actually assume your risk is going to be zero. Oh, sorry, the risk is going to be zero. Yeah, if you're walking, if you're not riding a bike or whatever, you don't have any risk. Okay, to other person. Okay, is there any comment or any question? Okay, if not, I'm actually going to make the CPP program very quickly. Okay, I'm going to make a very quick CPP program to show you that it's not that easy, but it's not that hard as well. because now traceable person, everything is fine. Now let me actually copy time location.cpp to time location risk.cpp. So I just need to modify this code. Over here, of course, is risk. And this is going TLR. And this is going to be time location risk. And I will say argument TLR. And before the sorting, everything is fine. Time location risk. Before the sorting, and this is going to be TLR. And JV pointer TLR. Okay, this part is just printing. That's okay. This part is, in fact, the TL sort is doing something like a bubble sort. The very, very typical way of doing sorting. This is very standard. I should probably make this into a pattern, by the way. This could be easily make it into a template, not a pattern, template. And then based on the template, we should be able to do this much cleaner. So so this is the one thing which I didn't do, template, but otherwise this should be fine. So I basically declare, you see this one, I'm just using operator overloading to compare those two. Everything is fine and the TLR. I want to make it to a point which I can compile the code. Then we know that we're done. Okay, so this is the same thing, TL unique. This is TLR. And this is the risk. And this is TLR. Okay, I think I should not probably waste my time here, waste your time here. I just want to tell you that you can actually start modify your code and such that you will be able to use this. If you implement this as a template, you probably will be a lot. The only thing I want to tell you is that when you do the operator overloading, when you do a comparison. Over here, we're using the time, but now we have a time begin and time end. So you have to compare. I mean, I just want to do one thing. The rest you can do it yourself. You can imagine that what you need to do. So over here, the way to do it, you have to change this part. You have to change this time begin is equal to another time begin and the other one is time end is equal to time end. Okay, and with this changes, then you essentially be able to upgrade your time location class to time location risk. Okay. Oh, another thing is interesting. I probably want to do this as well. Let me see. Time location risk h. I probably want to do this. I want to do a risk score. So the other thing which I feel if I care, okay, this is depending on your application scenario. But I can say if they're going to be the same, I think their risk score need to be the same as well. Okay, if you've done this, essentially I modify based on the new classes. Okay, it should be it's just pretty mechanical. It just follow this style. Okay, so that's the new class we call time location risk. And based on that, I hope I convince you I can have a very simple person object, which is actually helping me to represent this information about the scenario, a person, in fact, what I didn't do is I didn't modify the person.h. I'm just directly using traceable person and modify the time location information, and I will be able to get this things done here. Okay, so now let's actually look at the next one. The next one is the location, the GPS location, but this one is actually the aggregate about the risk score and with the time location information. Okay, so now let's look at our GPS class. So at the moment, we have GPS.h labeled GPS, but we also have a personal time GPS record, which we just use. We're not going to use that because that's actually individual GPS record. But what we want is for navigation, we want to have a GPS location that's represent a particular point, their risk at certain time. So I'm going to use label GPS as the basis. Oh, I want to first write the JSON, by the way, I forgot. Sorry about that. I'm actually going to write the JSON for this. So this is the location risk. I will call it location risk. And the JSON will looks like first, it has everything about a label GPS. That's already there, defining label GPS. But on top of that, what we want, let me actually take a look at the pic, what I did. Okay, over here, I can actually just do a location risk, but I'm going to have a vector. I call it time risk. Time risk, I would just say time risk. It's an array, it's a vector. And inside the vector, it has a bunch of information. So it has a time begin. Time begin is an object. Wait a minute, time begin is an object. Yeah, that's correct. And then we have a time end, which is also an object. And then finally, we have a risk score. This is, I call it aggregate risk score. This is going to be a double, a number between 0 and 1. Let me put a 0.5. Sorry, I make a mistake. I should make this an object. It's a vector of such object. You have multiple of them. Okay, another time this risk may be 0.75 or something like that. Okay, so what I want to do is a location risk. For each of the location, I essentially aggregate all the risk score from all the people that might passing through this location at certain time. And I want to aggregate this into this, I call a location risk. Okay, so this is the JSON I would like to develop during the scenario. And then, for example, I can say this part is the location is for University Row. Because University Row is one of the example of a location, okay? Okay, now I'm going to change this into a C++ program. I want to copy label GPS. I call it uh, label GPS risk .h. Now I can modify the code. Oh, I have to change from beginning. First, I want to say I change this to risks or risks. Over here, I just need to include label GPS. And over here, I'm actually going to say label GPS risks is equal to inherit from label GPS. And then I don't need this label anymore. And then this, I will have a risks. And this over here, I have a risks. Okay, now I have to think about what attribute I miss from label GPS. I'm going to turn that into label GPS risk. So let's take a look at the design that we have in the this is when I need to look at my what I call the JSON representation. So I need to have a variable called time risk, and the time risk is about the time duration and the risk score. Let me actually take a look at my other design earlier. I think I might not have I can have the time location risk. Let me see if I can use this one. So I already have this time location risk. Why not just reusing time location risk? I can do that actually. Okay, I can actually use time location risk. Why not just directly using time location risk? Yeah, I can actually direct. In fact, I will argue I don't need to create this new class called now I actually sorry, I this is my bad. Okay. I realize I don't need to create this new class called label GPS because I already have time location risk, which is very close to what I want, except it doesn't have a like a vector. It has pretty much everything. If I use this risk score not as an individual person's risk score, but as an aggregated score, then this particular thing is already fulfill everything I want. The only thing I might change is the GPS location. Maybe I want to change it to be labeled GPS. So I'm going to change this one. So this is object-oriented programming. We always make changes here and there in order to get it to work. So I'm actually going to use this one, and I'm going to use label GPS over here. Okay, over here, you can see I have now, I just create one class called time location risk. I actually be able to fulfill my second part. So what I need to do is just some so what I need to do is now I have this definition for time location risk. And so for each of the location, we have multiple of those. So now let's actually move on to the navigation and then try to come up with based on this design. Okay, we're almost done with this. So obviously during this process, you realize this particular JSON can be, by the way, when I did what I just did, I need to modify this. So maybe let me just modify this. I actually have I actually should revise this one. So I should have a GPS, label GPS. Which is an object. And then I have time begin. And then I have time end according to what I just did. And then finally, I'll have a risk score, which is a number. Okay, this is just represent regarding for a given location, I will have a multiple of this. For a given location, we will have a bunch of the following object. And they're all the same except they're representing different time duration. So for example, the time duration could be for the final exam. What's the starting time of the final exam? What's the finishing time for the final exam? And things like that. You can actually do even during the day, say from 2 a.m. to 6 a.m. What's the risk over there? Okay, so that is the risk. By the way, the risk is interesting. It's not just represent the traffic. You could potentially, for serial killer, the example, that could be another score that you can actually factor into the risk. Okay. All right. So we're good for this one. For the person, we actually make very small changes. And for the location, we kind of using this the new class we just created. And then now we kind of finally we can do a navigation. We can do a navigation. Okay. So how do I do the navigation? So let me actually first define a JSON for the navigation. So a navigation should be a sequence. What I call this? A sequence of time location risk. So if you think about that, this is so let's copy the location. The location is over here. So a time location risk is that you're going to navigate. For example, the first one is, I call it Ziqiang campus. What's the risk score? And the second one, let me just pick up this part, and then the rest I'm going to neglect. This is the first object, and the second object I'm going to go to Chenggong campus. And the risk score is 0.999, especially after past Sunday. Okay, we're actually getting a lot higher. And then we're going passing through, sorry. Finally, what do you call this? Guangfu Xiaoqu, is that right? Guangfu. And Guangfu is 0.2. Okay, assuming this is a one pass. One of the navigation, a sequence, that means you're suggesting people to walk from Ziqiang to 成功, and then to the 光复, and the risk score, we might pick the highest. So the risk score associated with the whole thing is a 0.999. Okay, that's the I mean, is one way to pick. Okay, so now I have picked another alternative, which is another navigation. Work from 自强, and then we go to not go to 成功, we go to 诚信. Chengxing campus, you kind of walk through that, and then the score is 0.7. And then from Chengxing, you actually go back to Guangfu. So I have a two GPS navigation. And in terms of for you to decide which one to go, I mean, the simplest way is I would pick the highest. So the first navigation, the pass, is the risk is 0.999. And the second one is only 0.7 because the NCKU hospital, sometimes they also have some risk associated with the taxi driver around there. So the risk is still high, but it's lower than the university road. So therefore, the navigation will suggest to you, oh, in this case, I will probably pick the second one instead of the first one. So the output of the whole program is going to print out the navigation as a service. Okay, so I hope I kind of convince you. What I did this today is from a very high level scenario to all the way go to JSON to represent what I want to achieve, and using very simple scenario, using example that I can convert it to a C++ program. And from that program, now if I come back to my first slide, I hope I actually convince you, our goal, convince to convert to scenario, and then we'll convert to C++. And then we're expecting, if your program is correct, then it will produce a JSON from the implementation, will pick a route with lower risk for us to be safer. And then we can look at the whole thing, whether the whole thing is reasonable, whether the service is something which is really, really what we desire to have. Okay, so let's stop here, and we will hopefully you got some idea about how to you proceed your final project. Tonight I won't be able to be in my office, but tomorrow night I will be in my office. So tonight I have another meeting in the evening from like 8 p.m. So I cannot be with you, but tomorrow evening I will be here. Okay, and you can talk about your project. Okay.